Okay, good afternoon, everyone. My name is Mr. Paul de Klerk, and I'm here taking over from Mr. Alex. He was kind enough to introduce me yesterday after his lesson, and I'm very privileged and honored to be here. I want to thank the STEM Lockdown Digital School for giving us this opportunity to have classes while this lockdown is carrying on, and let's hope that it doesn't last too long so that we can all get back to school and back to our friends. I'm sure you're all missing your friends. If you're anything like my son, it's one of his biggest complaints at the moment. So I just want to run through a few things quickly. The chat box is there for us to communicate and for you guys to answer some questions when I ask them. I'm going to ask you to try and keep it specific to the lessons that we're doing here. And then just for now, because I'm not too sure if you can all hear me, just type a yes in the chat box if you can hear me and if everything is set up correctly. I believe it is. Okay, perfect. Tyrone, I see you saying yes. Great. Banolo, everyone. Good. So I think we're good to go then. We are on the subject of natural sciences. You guys have done so well with Mr. Alex that you've actually completed technology term 1 or term 2. So we found it a good idea to go back and start with our revision of term 1 for natural sciences in preparation for the exams that are coming up. And I know in June you guys will have some big exams if everything falls into place with us having the opportunity to go back to school. So on the screen you'll find my email address, and if you have a notepad with you, write that down. If you're on a device, take a screenshot or a screen capture so that you can send me through your answers and any questions that I might not get to during this presentation. So let's dive right into it. Okay, so now we're going to do some revision and we're going to discuss the answers for the questions that Mr. Alex gave you yesterday. So the first one says, in your own words, explain what the biosphere is. Okay, let's have a look. So the biosphere is where life exists on our planet, including the soil and rocks, water and air. If you did mention something there down the lines of bio means life and sphere means round, that's also good. It's always great to try and elaborate on your answers where you can. The next one says, draw your own illustrations of the biosphere showing all its parts. Now, I'm no artist myself, so I use the same illustration that Mr. Alex used yesterday. If you drew a picture, good on you, and then just make sure that your picture shows these three components of the biosphere, which is the atmosphere, the hydrosphere, and the lithosphere. And just a small tip for when you are doing illustrations in science, it's always a good idea to put these annotations or labels on the pictures so that we can more clearly see and understand what it is that you are trying to communicate, and it shows your teachers that you have a good understanding of what the question asks. Right, the next one is, what is the scientific name for living things? And I know someone answered this in class yesterday already, and that is biotic. And the next one, give two types of living things. There we have plants and animals. And then name any three factors living things cannot survive without. So we have there gases, which is oxygen. We all know that all living organisms need to be able to breathe oxygen, and they need to be able to derive energy from food. And then the last one is water. And we know that no living organisms can sustain life without water. Okay, so here is a bit of a table, and it is with regards to these three components of the biosphere. The first one, the lithosphere, then the hydrosphere, and then the atmosphere. So in the chat box, quickly tell me, what do you understand under the term lithosphere? What does it refer to? Yes, good. Ground, land, ground. Tyrone, Fikile, Amu, land. Yes, great. So the lithosphere refers to soil and rocks. So that's the land. Now, it's important to remember, it's not only living organisms that live on the soil and the rocks, but also living organisms that might be alive in the soil and rocks. Mark saying he's late, no problem. We're just doing some revision at this stage, so you haven't missed much. And then, as I'm seeing this now, if you guys do miss the lessons or you missed a part of the lesson, remember that they're all uploaded to the Africa Teen Geek YouTube channel, and you can go and head over there and have a look at the videos, the recordings, if you did miss something here, or if you would like to revisit something. Okay, so back to the lithosphere. We said lithosphere is soil and rocks, and it refers to sorry, Kendra. Okay, it refers to animals or living organisms not only living on the soil and rocks, but also in soil and rocks. So an example of an animal that lives on soil and rocks is this lizard that we have here. And some lizards actually nest in the soil and rocks as well. So it just goes to show that our previous statement is correct. This is not the only animal that lives in this part of the biosphere. There are many other examples. Okay, so the next one is the hydrosphere. So in the chat box, quickly tell me, what is the hydrosphere? Yes, there we go, Devang, quickly. River, ocean, water, and sea. That's correct. Water, water, there we go. So the hydrosphere, as you all said, is water. Now, animals that we can find in water, that's pretty obvious. Fish, and here we have a photo of a whale shark, and some fish swimming around there. So that is a good example of animals that can live in the hydrosphere. So here we go on to the next one, the atmosphere. What is the atmosphere? Oh, you guys are so quick in this chat box, even faster than I could talk. Air, oxygen, and gases. And there from Bella, we already have the type of animal that can live there, and you are right, it is a bird, right, or birds. So this is a fish eagle, an African fish eagle. And if you haven't yet, do yourself a favor and go and Google the sound of this African fish eagle. It has a very, very distinct sound, and it's an awesome sound that's very native to our South Africa, where we live, in this beautiful part of the world where we find ourselves. Okay, so these are not the only living organisms that can live in these components of the biosphere. If we have a look here, we can see that there are other living organisms. Now, there is an organism that you can find, or types of organisms that you can find at all three of these components of the biosphere. Quickly in the chat box, what do you think that is? There we go. Jana's the first one. Bacteria, that's correct. So bacteria is also a living organism that we find throughout the biosphere, and it is present in all three of these components of the biosphere. Okay, so let's then fall into today's lesson. And today we are going to speak about the 7 life processes. So at the end of this lesson, I hope that you will be able to identify the processes living organisms perform. And I also hope that you would know what living organisms need to do in order to be classified as being alive. Yes, Mrs. Gren, I see a lot of you guys have that abbreviation down. Now, before we even get into this, I just want to tell you that the order in which you write these 7 life processes doesn't matter. I have them in a different order than the abbreviation that you have, and the only reason is it is easier for me to teach it in that way, but for you to remember it, Mrs. Gren is a good abbreviation to learn. Okay, so before we fall into that, there are some new words that we will encounter today during this lesson. So the first one is sustain, and sustain means to keep things alive. And the next one is requirement, and requirement is something that is needed or that you must have. And the last new word that we will see is going to be favorable. Favorable is when we make something more likely to succeed, and we'll touch on that a bit later on in more detail. So, as we've said, there are 7 life processes, and in no particular order, I'm going to introduce them to you one by one. So we have movement is one of the processes, sensitivity is another one of them, nutrition is there, respiration is there, excretion is there, reproduction is there, and growth is there. Good. So now we have the 7 processes. Let's get into that. Yes, it's not flavorable, it's favorable, but that's a good catch, Kiandra. Okay, so let's get into each one of these different processes a little bit more in more detail. Okay, so the first one is movement. Now there are different types of movement. So you can see here in the picture at the right top, there are big movements like that horse running down the racetrack. And that's not the only big movements that there are. If you have a younger brother or sister, or even if yourself still like to jump on the bed, then that is also going to be classified as big movements. Now there are also small movements. All plants actually have movement. So if we have a look at this picture here, this is a picture of a sunflower. So this sunflower moves in an array of different ways, and it's not only the sunflower that moves that way, most plants do. So a couple of ways that plants can move is the first one, when plants are growing, you can actually see them moving, and they grow as they get taller, so they're moving in that way. They also grow and move when the roots of the plants are growing deeper into the ground or spreading in the ground to stabilize the plant. That's also a form of movement. Now, the form of movement that the sunflower is most popular for is obviously the fact that it follows the movement of the sun through the air and through the sky. So as the sun moves, the sunflower's face will turn to follow that. So another interesting fact, and the last interesting fact, is some flowers and plants actually close completely during the nighttime. So they close their faces completely when the sun is gone, and then they open it again in the morning. Sorry, I'm clicking on the wrong thing here. Okay, the next life process that we're going to be looking at is going to be sensitivity. All living things need to be sensitive to their environment. This means using their senses to be aware of changes in the environment. So, an example of this would be if you are feeling cold, then you would go and you would put on a jacket. So, your senses tells you it's cold, but then you react to the environment through your senses, and movement happens, and that movement is you putting on your jacket. So, let's have a quick look here at this, another example. What senses does this animal need to use in order to not become a lion's dinner? So in the chat box, quickly put there, what senses will this animal use to not become a lion's dinner? I see sight there, I see smell there, hearing, there we go. So you are all correct. The answer is hearing, smell, sight, and any other senses that it might have, such as feeling, to realize that there's a lion hunting it. And the reaction to the environment after these senses have happened is big movement. The zebra will obviously run away, and that is going to be the reaction to the environment that it is feeling. Okay, so the next one is nutrition. Now, nutrition comes from food. And here we can see that all living things need to break down nutrients during cellular respiration in order to release energy. So this being the cellular respiration, we'll have a look at in the next slide. So, okay, I'm going to pause here quickly. I see Doritos has a question. Yes. Okay, Doritos, that is a question that we will answer when we get to that lesson. I'm going to ask it again, as I see there's a lot of chat happening in this chat box. This chat box is specifically related to the slides that are on the screen at the moment that the questions are asked. So if you have any more questions that expands further than the scope of this presentation, please send it to my email, and I'll see if I can give you some resources and answers with regards to that. Okay, so let's get back to the work. Nutrition, as we said, comes from food, and all living things need to break down nutrients during cellular respiration in order to release energy. So if you can see there, cellular respiration is something we'll speak about in the next slide. But let's have a look at this photo as an example. So there you can see the zebras are eating the grass. Well, they're not eating the grass, but they eat the grass. Now, the grass is what gives nutrition to the zebra. The lion, in turn, eats the zebra, and that is where the lion then gets its nutrition from. Right, so I said that we'll have a look at this respiration, and the scientific word for that is cellular respiration. And what that basically means is, very simply, is when organisms release energy from their food. So we saw in the previous slide that nutrition, they get it from food, and that nutrition is turned into energy through a process that is known as cellular respiration. And that is where the energy comes from that allows living organisms to move and to be. The next life process is excretion. Now, all living things need to be able to excrete waste. So what happens is our bodies and other living organisms, they don't only take in nutrients that is always good for them. For example, if we breathe the air on a busy road, we are not only going to be breathing in oxygen, we will also be breathing in some carbon dioxide, which comes from the exhaust gases of the cars. So in a way, our bodies need to get rid of that waste, because waste can turn into toxins that is not good for your body, and it can make you ill. So if we have a look at this, an example of this would be sweat. So when we exercise or when it's really hot, our body sweats, and that is one of the ways that our body gets rid of the extra waste, and it excretes that waste. And this is the effect of sweat happening there in that illustration. You can see there is a stinky sock, and that's what happens when we wear our socks the whole day, and then we get these things, this smell that's happening there from the sweat. Okay, let's carry on to the next one. Reproduction. Without reproduction, living organisms will die out. So some examples that we have there are babies. Animals have babies, and as you can see there, the cat has baby kittens, and when those kittens grow up, they will have kittens of their own, and so the life cycle can continue. The same thing happens with animals. With plants. So plants give off seeds, and these seeds grow into new plants, and so these living organisms can continue and they will not die out. Okay, so now we're looking at growth, which is the last process that I have here. Sorry, I'm just quickly checking into the chat box to see if I can answer some questions here. Okay. Yes, guys, as it's been said here, let's keep the chat to the work so that we don't have to be forced to block it down. And for those of you that feel you might be in a grade 5 class, remember this is a review class. So this is obviously work that you guys have done before, and you've even written exams and tests of this as well. So just bear with me while we do this revision. I'll try to make it a bit more interesting as we carry on. Okay, so growth, when animals or plants get bigger, that's the basic definition thereof. And then if you can see here, if we have a look at the salamander as an example, they might even undergo much bigger changes than just becoming bigger. You can see that the salamander's entire shape changes from being a tadpole into becoming an adult salamander. Okay, so now we're going to get into the next phase, and we have to obviously understand the life processes before we can get into this. And this is sustaining life. So now that we know what living organisms need to do in order to be classified as living, let's inspect what living organisms require in order to stay alive. So it stands to reason that if we understand the life processes and the processes that needs to happen for life to be there, that we can now derive from that information what is needed to allow those life processes to happen. And this is what science is all about, trying to figure out how everything works and forms together into one big universe that we live in. Right, so before we get into understanding the life and sustaining life, I quickly want to ask you this question. Let's create a scenario where we say, okay, there has been some radiation that's making the atmosphere that we live in, it's unbearable for us. We cannot function and survive in this atmosphere. So scientists have come together and they have created a dome underwater, and that is the place where we all have to move to, and we have to live there for 100 years. They say that after 100 years, the air will be good and we can move back into the atmosphere. So what things do you think will we need to be able to survive in an underwater base for 100 years? Yes, the answers are pouring in there. Great. Food, and there's a picture of a hamburger. It's definitely something that I would need. Okay, yes, you are all right. So I'm going to show you some of my answers here. Now, these aren't the only ones, obviously. These are just some examples to get your mind working in the same direction. So the first one, as you've all probably guessed, is oxygen, because we need to be able to breathe. The next one is going to be food, as you guys have mentioned in the chat as well. Water, we'll definitely need some water, because as we know, water sustains life. Warm clothes. Now, I'm saying warm clothes, but what this actually refers to is, we saw this in the beginning, favorable temperatures, because let's say that we are deep underwater, the sun wouldn't necessarily reach us there. So we would need to create a space where the temperature is sufficient for us to be able to function. Lights do the same thing. It is also there for temperature control, and then it helps us to see so that we can avoid dangers in our surrounding areas. We need to use our senses, as we saw with sensitivity, which is one of the life processes, right? The next one we have there are beds. It doesn't necessarily have to be beds, but a place to rest. There needs to be a place or a space for us to be able to rest, for our bodies to rejuvenate. And then this one is more of a joke. It's not that important, but judging from how you guys are using the chat box, you are obviously going to need Wi-Fi. Can you imagine living somewhere without internet access for 100 years? Again, that's a joke. That's not necessarily needed, but just something to get your mind going and thinking about. Okay, so living organisms require certain conditions or things to be able to stay alive. We say that these things or conditions sustain life. So these conditions are energy, gases, water, soil, and favorable temperatures. Okay, before I carry on, I'm going to head back into the chat box. I see it's buzzing here. Let me see if there are any questions. Just going back here to what we need. Junior says that he'll need money as well. And then Gao said yes, Wi-Fi. And Fikile says that they have a question. Yes, put your question in the box and I'll see if I can answer that for you, Fikile. Fikile has a very good question. Where would the waste go? So that is something that you can actually go and do a bit of research about. There are a few projects where scientists have gone and they have tried to replicate life. So there's a dome in the desert in the States, as an example, where they are trying to replicate an atmosphere so that they can see how they would sustain life on another planet. So Fikile, go and do a bit of research on that. I'll do that as well. Send me an email and then I can send you the articles on that, and then we can have a look at what they are doing to get rid of the waste that happens from the plants and the animals and the people that will be living in there. Okay. So just to recap on this slide quickly, living organisms require certain conditions. These conditions or things, we say that it sustains life, and these ones are energy, gases, water, soil, and favorable temperatures. So let's have a look at each one. Energy. All living organisms need energy to stay alive and perform the life processes. Plants need energy from sunlight in order to photosynthesize. Other organisms get their energy from the food that they eat. Now, if we have a look at this cow in the field there, we can see that the grass and the trees gets its energy from the sunlight, and the cow then in turn gets its energy from the grass that it eats. So we can see energy is derived from food, which was one of the life processes, nutrition. Okay, the next one, gases. All living things require oxygen for cellular respiration. There's that big word that we learned about during the life processes again. Oxygen is used to release energy from nutrients and carbon dioxide, and water is produced as a waste product of respiration. I'm just going to read that sentence again. Oxygen is used to release energy from nutrients, and carbon dioxide and water is produced as a waste product of respiration. So green plants also need carbon dioxide to photosynthesize. And here's an example of that. This dog is getting energy from the air that it is breathing in through its nose. So this is one of those things where we can again say why air is important for us, and the gas is oxygen. It allows cellular respiration to happen, and the way that we consume the air or the gases are through our noses and mouths. Okay, so next one, water. Water is vital to life. Every organism on our planet needs water to live. We are all aware of this fact. So, here's a good piece of information. Did you know that when astronomers search for life outside of our solar system, they search for planets that might contain liquid water, believing that where there is water, there may be life? Now, I have a quick question for you. Before I ask that question, I'm just going to go into the chat box here and quickly have a look at if there are any questions here. Okay, so people are still ranting on about that underwater dome. Just have a look. Air comes from trees. Okay, Joanna, photosynthesis, the process by which green plants make energy using energy from the sun. Yes, that's correct. And that is also the way that our oxygen gets released during the nighttime. They take that energy and it gets changed into oxygen. They use energy to grow themselves and feed themselves, and then the excess energy gets used to create oxygen for us to breathe. So my question for you is this. If you have a look at this little block here with the picture of the astronaut on there. Okay, Kilia, I'm going to move closer to my computer. Hopefully that helps. If we have a look at this statement, it says there, when astronomers search for life outside of our solar system, they search for planets that might contain liquid water. Why do you think they say liquid water and not just water? What is the reason behind that? Anyone have any ideas there? There we go. Lefa sent me a private message saying there might be an icy planet. Kushi said the same. Joanna said because we drink liquid water. Amo, if the water is solid, as in iced, we would not be able to drink it. That's correct. Okay, Vincent, a lot of organisms need water to survive. Yes, but this is specifically referring to water in its liquid form. So everyone who's answered above, yes, you are correct. Water in its frozen form, in the form of ice, is not enough to sustain life. We need to be able to melt the ice down into a liquid form of water, or water as we know it, that we get from the tap. So yes, some planets might be so cold that it wouldn't even have we wouldn't have the ability to melt the ice that's on that planet. So that also brings us to our next slide. Just quickly here. Oh no, I'm lying. That's the last slide. For now, let's just have a look at this one before we go there. Soil. Oh, let's skip. I'll come back to this one. I quickly want to show you that one. Favorable temperatures. So we just spoke about this, where we said water and ice and how it needs to be in a liquid form. So this actually is a part of that whole idea. Favorable temperatures. All organisms are adapted to live in a particular temperature. In general, our planet has favorable temperatures to support life. Earth is at an optimal distance from the sun so that it is not too hot like on Mercury, and not too cold like on Neptune. So there we have that exact idea. If we are on Neptune, we might struggle to get the ice melted into the liquid form. Okay. The last one that we have here is soil. So soil sustains life on Earth. Most planets depend on soil for support, minerals, and water. Without the soil, plants would not be able to produce the food that animals and other organisms depend on. So if we have a look at that yellow circle around the base of the tree, oops, just try and get back there. There we go. It's spinning around to draw your attention to it. There we can see the roots of the tree that is growing into the soil. And those roots in the tree or into the soil at least, is helping that tree to stay upright. So it supports the tree. What it also does is those roots take the minerals from the soil to feed the plant. And that is also the place where the tree or the plant absorbs the water that it needs to function in the way that it is supposed to function in. Okay, so now we're back to favorable temperatures. We read through this, and in this slide we can see there that Earth is not too hot and it is also not too cold. And that is the reason why Earth has favorable temperatures to sustain life, and other planets, they don't have that favorable temperatures, or they haven't discovered planets that have that yet. Okay, so now we're going to do a bit of a recap quickly. We ran through this a lot faster than I expected. So the life processes. How many life processes are there, did we say? 7, that's right. Correct. There are 7. Okay, just start naming random life processes. Let's see how many we can get. Good. I see sensitivity coming up a bunch of time. Movement, respiration, excretion, nutrition, and yes, all of the above. So the first one was movement. And remember, we said that there are different types of movement. Big movements, as in the animals that are running around in the fields. And as we people, we also make big movements when we are sprinting or running. The next one is nutrition. And we said that nutrition is what we derive from the food that we eat. Then we have sensitivity. This is where we use our senses to be sensitive to our environment. Not only us, but any living organism, where we had the example of the zebra, and the zebra uses its senses of smell, hearing, sight to sense when danger is close by, and then the reaction to the environment is then big movement in the form of the zebra running away. And we have excretion, where we said that excretion is the body's process, or any living organism's life process, of getting rid of waste. And then we have reproduction, and we said that without reproduction, a living organism will die out. And then we have respiration, and that is where we said our body gets the nutrients from the food that we eat, and then those nutrients gets changed into energy that we use for movement. And the process of changing the nutrients into energy is called cellular respiration. And the last one is growth, where we had the picture of the salamander that changes from a tadpole into a fully grown salamander, and that's the same when it comes to frogs and toads. And that's not the only form of growth. Some things just get bigger, other things might change completely, like in the example of the salamander. Right, let's quickly hit to the chat box here. There we go, Joanna, that's correct. The process of the tadpole turning into a salamander, or the tadpole turning into a frog or a toad, is known as metamorphosis. And they're a bit higher up, Joanna also said, and plants make small movements. Yes, plants make small movements. So quickly in the chat box, tell me, I said that I mentioned 4 different ways in which plants can move. Answer in the chat box there some of those different ways, some of the types of movements that plants make. They move towards sunlight, yes. Yes, through the roots that grow into the ground. When there is wind, Joanna, that's correct. But now, this is why I asked this question. If something is moved by the wind, does that mean that that thing is living? No. Nope, there we go. So you all got that one right. It's a good way for me to see that you really understand what it's about. So a life process is one of these things that that specific thing has to do without an outside force or an external force causing that thing to happen, like in the case of movement. So if we say that a plant has movement, it has to be movement that the plant makes on its own. It can't be movement that is happening due to wind moving it around or due to people walking there and stepping on that or whatever the case might be. Okay. Right, so let's have a look at the next one. Sustaining life. We said that there are a few things that is needed to sustain life. So the first one was energy, and again that we said is in the form of the food. Plants such as trees and grass, they get the energy from sunlight, and then trees and grass, they get the energy from sunlight, and then animals get the energy from the grass that they eat. Soil, there obviously needs to be soil for the plants to grow in. Water, as we've mentioned before, all living organisms need water to be alive and to sustain life. We mentioned Earth has favorable temperature to sustain life because it's not too hot and it's also not too cold. Okay, so here is your homework for tomorrow, and I want you to, if you have a notebook with you, just write these down. If not, and you are on the device, take a screenshot or a screen capture. After this, the next slide will show my email address where you can send the answers to, and we will also discuss them in tomorrow's lesson. So the first one says name 3 of the life processes. Remember we said there are 7, so that should be easy. The next one is can plants move? And if yes, how do they move? Again, remember, here we're not going to answer how something else is moving the plant. We want to know how the plant moves on its own. The next question we have there is what gas do living organisms need to sustain life? And the last question, why does Earth sustain life? Name 2 reasons. If you want to, I think we have about 5 minutes left. You can quickly jot some of the answers in the chat box so that I can just be sure that you are understanding the questions that are on the screen. Okay, excretion is one of the life processes. Yes, Devang. Movement, yes, good. Nutrition, yes. Sensitivity. Okay, number 1, respiration, growth, good. Kile, reproduction, yes. Okay, so you guys can obviously see the questions there, and I will be looking out for your answers. We will also discuss them tomorrow during the next lesson that we have tomorrow. So if you are willing, you can answer those homework questions, and then you can send the answers through to my email address, which is on the screen right now. You can write it off, or you can take a screen capture. And then tomorrow's lesson, and this is your invitation to attend tomorrow's lesson, is going to be life and living again. And tomorrow we will be speaking about biodiversity. Just as a thank you and a final goodbye, I want to invite you all to follow us on Africa Team Geeks, and to give us a like and a share and a follow wherever you guys can do that. And then also remember to hashtag your answers with Cecil Foundation, STEM Champions, and the Lockdown eSchool. Right. Thank you very much, and I hope you guys enjoyed that lesson. I'll try to make it and keep it interesting for you guys. Goodbye.